Good afternoon everyone, it's Joe, Jazz Land Rovers again, and we're in the workshop this evening. It's Friday evening, everyone else has gone home, and I'm just going to try and talk you through one of the faults we've had in today. It's not really about diagnosing this specific fault, but it's a good lesson in why it's important to sometimes not believe your multimeter and do a separate test on this particular one, which I'll show you. So, workshop today, we have Discovery 3, that's where we'll be working on shortly. Range Rover Sport that's just had an engine fitted, that's the engine right there, and another Discovery 3 in for some service work. But this is our Discovery 3 we're going to be looking at. It's early one actually, it's 2005, but it's in wonderful, I say wonderful, it's for 2005, it's in amazing condition. Not bad at all, paintwork's lovely, interior's nice, etc. Underneath, it's pretty standard Discovery 3, other than there's barely any corrosion, it's really nice. What fault did we have then? This car came in with a flashing red handbrake light on the dash and a handbrake warning message if you ever pressed or released the handbrake button. The emergency release had been pulled, we got that from the customer. The recovery service did that to get them moving again. Didn't say anything if they'd pulled any fuses, didn't say anything if they'd done any other checks, just that they'd pulled the emergency release, the handbrake then did release and they were able to carry on driving. Read the fault codes quite predictably for having pulled the emergency release. One fault code logged for emergency release has been pulled, and that was that really. We'll talk a bit more about that particular fault code and why it leads into what the actual fault was in a bit. But a little bit about the Discovery 3 if you don't know. It's got an electronic handbrake. Behind this plate is an electronic module that pulls on two cables. Give it a touch. This cable at this side, this cable at the other side. Each cable goes into the drum and actuates some handbrake shoes inside the disc. You got one switch inside the cabin. Pull the switch up, activates the handbrake. Push the switch down, releases the handbrake. The handbrake module itself is part of the high-speed CAN system. Communicates with powertrain control module, ABS module, and so on the high-speed CAN. I've got my wiring diagram, so we can just have a quick look at that. Having said that, I'm not sure how well the camera will focus on this wiring diagram, but we can give it a go. Let's go down here. Again, I don't know how well you can see this stuff, but inside this box here, that's our handbrake module. It's got a motor in it. We've got a battery junction box, ignition switch, central junction box. Because this is a manual, we also have a clutch position sensor. On the back we have all the other modules that this module communicates with, so air suspension control module, ABS module that I mentioned, transfer box control module, transmission control module if it had one, and here's our module again, and 4 wires going to the switch. We've also got engine control module, instrument cluster, and that's that. It's quite a lot that it does. It's quite a clever system, usually quite reliable if serviced well. Generally problems arise when the mechanics of the system, the mechanical elements of the system don't get serviced. They start to seize up and they cause issues with the module itself. Right, the fault that we had. Emergency release has been pulled. It had been pulled, but it would not clear even after the emergency release had been released, if you like, after it had been let go. The emergency release is a pull cable. It enters the underneath of the vehicle there. It's that cable. So then routes along the fuel tank, over the top of this cross member, and into the module. Up there, I've actually got the cover off the module to do some tests inside it as well. That's the emergency release cable. So when that's pulled, it releases a pull inside the module that releases the cables. So the cables are no longer pulling on the drum, on the shoes inside the drums, and the handbrake is released that way. That's all fairly simple. Now if we get into what else is inside the module, we've got a motor that is used to move a gearbox, and the gearbox then moves some sliding, like a slider, and the slider pulls on both cables simultaneously to bring on the handbrake. The release basically splits that slider, and then so the cables can then move independently of the motor. What else do we have in this system? We have a load sensor, which it's inside the module again, and it detects how hard the motor is having to pull on the cables. And the motor and the load sensor is essentially what the module uses to log the fault code that we've got. There's no actual sensor on the release cable, but if the release cable has been pulled and hasn't relatched or hasn't been relatched, if you pull the handbrake on, if you pull the switch up, the motor will move. If the motor moves and the load sensor doesn't detect an increase in load, then it will assume that the emergency release has been pulled, because it assumes that that's the only way that you could get no increase in load after actuating the motor. If you think about the system a bit more, imagine if some recovery drivers, to get you moving, instead of pulling the emergency release, some people will cut the cables that we talked about. So even though the emergency release hasn't been pulled in that instance, you pull on the handle, you pull on the switch, the motor will move, the cables will move, but the load sensor will not detect an increase in load because the cables aren't pulling on anything. So that would also log as a emergency release has been pulled fault message or fault code. That's not what's happened in this respect. What we've got in this instance is pull on the switch and the motor doesn't move. So we're going to do a few checks. I'm going to talk you through what I've done, where we could have fallen down with our diagnosis, and what we did to make sure we didn't make a mess of it, essentially. I'm going to start underneath here at the back, and I'm going to try and stand this little camera up somehow. I'm not sure how that's going to go. So I'm just going to hold it. So much for rehearsals. Right, as I say, our module is behind this cover. These wires here, or not that, but this wiring loom and this wiring loom here are the parts, the wires that go into the module. They come from this side of the chassis rail and go all the way towards the front of the car. Actually, some of them enter the body up here. That's up here. And some others go along the front of the chassis rail towards the battery. I'm just going to grab that connector out, and we're going to do our tests at that connector. If I can get my hand in there. Something like sorry, this came out easier earlier. There, that's our EPB module connector. You can see female pins or female connectors on this side. Inside the module at that end is a connector with lots of male pins. If you look really carefully at this, actually, you can see lots of small pins here and some bigger pins at this end. That is important for a reason that will become obvious as we go through some tests. If we look at our wiring diagram then, you may not be able to see this, but I'll do my best. Here's our module, and that part there says VBAT, as in V battery, as in voltage battery. So these two wires should give us battery voltage straight from this 30 amp fuse, which is in the battery junction box, fed directly by the battery. So this wire, it's not ignition fed, there's no fancy electronics, it's literally just battery fuse connector. So we can test that. So these two wires, which are both fed by the same wire after this splice joint. So this is battery voltage in after the fuse splice joint feeding 2 wires to the module. That's our permanent power supply. We'll check that. We'll just go quickly look at that. We've already checked the fuse. The fuse is fine. And we'll go and check this here. So a quick bit on setup. We've got multimeter here, reading volts, or reading DC volts. Ground wire goes all the way to the battery as a known good ground. Ignore this for now. And this is our probe. It's a back probe, but we're actually going to put it in the front of the connector to show you what we've got. So multimeter is telling us 0 volts. This is our green and yellow, the 2 green and yellows. They go to this pin and the pin next to it, sorry, the pin down from it. I'm going to stick it in the end one for now, just a second. Right, that took a little bit longer than expected. But here's our probe into, I think it's actually H4 they call that pin. And my multimeter's turned off. So voltage there, 11.4 volts. Battery voltage nearest damn it. Bearing in mind I had a door open a minute ago, so that's flattened that slightly. Put it into the other pin, fed by what is effectively the same wire, remember? Also 11.4. So we've got battery voltage at our 2 permanent power supply pins. Simple, you think, hey? That's one check done. We have a power supply. If we look at the other power supplies to this module, here we have IGN for ignition, and under that key in, that's more of a sensing input. But ignition is ignition power, and if we look back here, that's our ignition switch. So at the top, battery fuse box feeds the ignition switch on, feeds the central junction box. In there we've got 1 fuse, 2 fuses. This top fuse, fuse 41, is a 5 amp fuse, goes through one connector into our module. The other one, just for sake of completeness, we've got another 5 amp fuse, same connector into our module. The bottom one, the green one, tells the module whether the key is inserted. It uses that, particularly again with a manual. When you pull the key out, if you're in neutral, it will apply the handbrake, so you don't roll away. But the ignition voltage at this one, I'm not going to show you because I've done it. With the key on, we also get ignition voltage at that pin, which is F3. F3 would be counting up from the bottom, A, B, C, D, E, F, and then counting across 3, 1, 2, 3. That one is our ignition switched live. That also has 12 volts. If you think about it logically, the biggest thing in that handbrake module is the motor. The motor is what uses most of the power, so we are going to assume for now that the 30 amp fuse is the fuse that feeds the motor. It's not an unreasonable assumption, and in fact it's true that that is the case. The 30 amp fuse, it also supplies power to the module when everything else is off, and the ignition switched feed, the ignition switch live, basically just tells the module to wake up and use more power from the 30 amp feed with the ignition on. But the motor is powered by that 30 amp feed, and we've got 12 volts there, so the motor should work. There's no other faults logged. I can plug Autologic in and I can command the module to move the motor, which it doesn't do, but it doesn't log any faults for open circuit, anything like that. After some more thinking about it, you could pretty much condemn the module. You could say it's got power, it's got ground. I didn't actually check that, but these 2 connectors over here are two grounds for the module. Basically as a pair, as a twin to the two feeds, the two big power supplies. If you've got power in, you've got to get power out again. Power to ground, those grounds are good. It's got power, it's got ground, it communicates, but it just doesn't activate the motor. At that point, just for the sake of finding out what exactly was wrong, you could say the module is faulty, as in the complete module is faulty, or you could say the module is faulty because the motor is dead. So I wanted to prove that the motor was not dead. To do that, I took the cover off the module, and I'm trying to get my torch set up a bit better here, so you can see what's going on. So this is the motor, this is our gearbox, this is the sliding mechanism that I mentioned, and part of that is the load sensor. You've got the circuit board for control, and then that kind of grey part at the top left is our connection, the connector block. On the motor, you can actually see you've got a red wire and a blue wire. The red wire and the blue wire are power and ground to move the motor in one direction, and if you reverse them, so the other one becomes power and the other one becomes the ground, the motor moves in the opposite direction as well. Come on, torch, get out of there. With the power probe that I have here, excuse me, that's this device here. It's just it's very, very simple power probe, the original power probe. This connects up to the battery, that's what this cable is for. It has its own dedicated ground, which you can plug onto things to give them a ground. And on the tip here, it's exposed metal, and with that you can push the top half of the switch, which says positive, and that'll light up red, and now that's 12, or that's battery voltage at the tip. You can also ground the tip by pushing the other side, so if you wanted to make sure your ground was good, you could touch that onto your wire, onto your ground wire, hold down the ground side, and it eliminates any ground faults in the wiring of the car, and it just grounds the whole circuit through the power probe. Similarly with the positive, you can rule out a dodgy positive by pushing down the positive, and it will supply battery voltage directly to whatever you click the tip onto. It's a really easy way to fry modules if you're not careful. If you put battery voltage into somewhere that should be ground, or if you put battery voltage into like a 5-volt reference circuit, you will wreck it again. So you've got to be pretty careful with them, but for something like we were trying to do, like we did do with this, it's fairly simple. We know from past experience that motor is a 12-volt motor, and battery voltage in this car is essentially 12 volts, so we can use it to directly power the motor. Red wire and blue wire, stick that on the blue, hold that on the red, give it power, and the motor moves. Just again, sake of completeness, that on the red wire, that on the blue, give it power, motor moves in the other direction. So the motor actually is perfectly okay. That leaves us with, having tested the wiring, remember, we've tested for battery voltage at the module connector. That leaves us with the module, the circuit board itself. But that is not the fault. But you could see how someone could have mistaken what this fault is for a module fault. We've got power, we've got ground, but we get no response from, and part of the motor part is good, but you get no response from the motor if you command the module to move it. You could assume that that was a fault with the motor, with the module, sorry. But I'm here to tell you, ladies and gents, that is not the fault. What we've got, believe it or not, is a wiring fault, and it's a wiring fault with these two permanent power supplies. The two permanent power supplies, remember, that have got battery voltage present. What we're going to do is prove the importance of what is called a load test, which is not just measuring voltage, because as I say, we've got battery voltage there, but the motor does not move, the module does not do anything. Why is that? So, first of all, let's look at our the high-tech system we have for load testing a circuit. If you'll just excuse the noise for a second. 2 seconds. Maybe even 3 seconds. Maybe 20. Right. This is where it gets technical, because now I have both hands free. This, see if this works. This is a load tester. That's a headlight bulb with 2 wires attached to it, one to one terminal, one to the other. It's a 55 watt bulb, 55 watts, sorry, and a nominal battery voltage of 12 volts give us a tested load of around about 4.5 amps. It's a 30 amp fuse in the system, so you might say this isn't sufficient to test the circuit. You can only pull 4.5 amps out of potentially a maximum of 30 for the motor. But it's going to prove what's going on in this case. Just to prove that the power probe works as well. This is how it works. I've connected one side up to ground, touch the other side to the tip, hold down the positive switch, and you get the light turning on. So that's how we test, or that's how you use the power probe to apply power and ground to a circuit, and it proves that our bulb works. It's always good to check that your bulb's still good. So how are we going to load test this particular circuit? Because we've got dodgy wire ends and some teeny tiny little connectors. I'm going to get my back probe, I'm going to take it out of the multimeter, stick it back in there. I'm going to use the ground. This is getting technical, far too technical for me. Use the ground, the proven good ground, because I've just tested it, of my power probe. And I'm going to stick this and hold it against that pin. There should be battery voltage in that connector. Remember we measured it, it was 11.4 volts. But if I hold that on there, our bulb does not light. So why is that? Maybe if I give it 12 volts from the same battery, if I give it battery voltage from the same battery, it lights up. Why does it not light up? We had 12 volts. We had battery voltage. Why does our bulb not light up? Well, that is the reason we do load tests. We load the circuit. We actually ask the circuit to supply power, not just voltage. We ask it to supply some current. And that circuit, these two thick green and yellow wires, are not capable of supplying even 4.5 amps that we need to ignite or to light up our our 55 watt bulb, our headlight bulb. Just making some noise again. Excuse me. I need a better tripod. Anyway, you may notice there's one wiring loom, a big thick one, and then there's an extra one. This is it's a dealership mod done years ago when there was a fault with these looms. There's nothing wrong with it. Lots and lots and lots of Discovery 3s have them. I say there's nothing wrong with it, there is something wrong with it, but it's not unusual to see it. Right, quickly back over the whole circuit. Battery, which is up here, feeds the battery junction box where our 30 amp fuse is, also up here. That power then comes down through this wiring loom. I'm going to drop this ramp down slightly. To a more manageable height. Right. That fuse, supplies power to this connector, this blue one. There's our yellow and green. Goes out of that side. Also yellow and green. You can't really see it, but it is yellow and green. From there, it goes along the chassis rail, behind the wheel, and over to the module. One other quick check we can do to find out where our fault is. Let's separate this connector. Let's carry out the same test over here. So here is load tester and power probe. And if we stick that in there, that's doing the exact same thing. Grounding one side, using power probe, putting power into the other side with the circuit. So it's not the whole circuit that's dead, that proves the fuse and the fuse board is capable of supplying power, and everything up to this connector is capable of supplying the power that we need for that entire circuit. So and here we go, here's how we find the problem. The problem is between here and our module. There's not a lot to look at, as in there's not many places to go looking other than, and if you excuse me, to move you something like this. You may recognise this is our air suspension compressor. That wiring loom, the additional one, they always got joined up in there. Can you see the green? That green up in the top. I can't really point at it. Ooh. All the way up in there. There you go, that's better. There. That's where our loom, the power supply for the module, got added into the original car loom. This wire supplies power to this point, and then we tee off it with that dealer loom to feed the module with power. So now it's a case of repairing that green bit of corrosion, and then it should all work. I've sort of tested my theory already in that I've put the power probe on the two green and yellow wires right by the module, stripped the wires back a little, and applied power directly into the module at that point with power probe, and the module powers up, the motor is able to be commanded to be moved, handbrake applies and comes off. Dead easy. So we've got to do, repair that bit, and she's fixed. But that is a demonstration really of how important it is to do load tests. There are other ways of doing load tests. You can load test with a test light sometimes, but a headlight bulb like that is a really good solid test of a circuit's ability to supply power. I think we're approaching half-hour mark now. That's not bad for one take. There'll be no editing, I don't think, not much anyway. And this video will be uploaded shortly. As I say, it's Friday evening. I'll show you, I'll prove it. There you are. And some music. That's it, ladies and gents. Friday night. Hope you all have a good one. Discovery 3, handbrake problems. Soon to be fixed. See you later, guys. Bye.